Hello, let's use the second derivative test to find the local extreme values of f of x equals 12x to the fifth plus 15x to the fourth minus 40x cubed. Now this is the same function as the example where we used the first derivative test. This is an alternative way to find your local maxima and minima. So to do this, we need to find our critical values. Specifically, we need to find where the first derivative is 0. Now, the first derivative is 60x to the fourth plus 60x cubed minus 120x squared. Now, in the last video, we saw that f prime of c equals 0 if c is equal to 0, 1, or negative 2. Okay. Now, the second derivative test tells us only what happens when the first derivative is 0, whereas the first derivative test will tell us something if the first derivative is 0 or it doesn't exist. So there's sort of a shortcoming of the second derivative test. But the second derivative test, sometimes the calculations can be quicker. In the second derivative test, we need to find the second derivative. So 240x cubed plus 180x squared minus 240x. And then it says if the first derivative is 0 and the second derivative is positive, we have a local minimum. If the first derivative is 0 and the second derivative is negative, we have a local maximum. And if the first derivative is 0 and the second derivative is 0, the test is inconclusive. It doesn't say anything. It doesn't say that nothing happens. It doesn't say that one or the other happens. It just is inconclusive. We need to do something else. So let's check the second derivative at each of our critical values. So at c equals 0, f double prime of 0 equals 0. At c equals 1, we have f double prime of x. That was 240 times 1 cubed plus 180 times 1 squared minus 240 times 1. So we have a 240 minus 240 plus 180, and that's positive. And at c equals negative 2, f double prime of negative 2. Oh, whoops, I should have made that 1. F double prime of negative 2 is 240 times negative 2 cubed plus 180 times negative 2 squared minus 240 times negative 2. Okay, and what does that give us? Negative 720. So now we use the second derivative test. At c equals 0, this is inconclusive. And actually the first derivative test gave us more information here. At c equals 1, we have a positive second derivative, so that tells us at c equals 0, we have a local minimum. And at c equals negative 2, we have a negative second derivative, so that tells us we have a local maximum. So what does this tell us? We can see that the second derivative is a bit quicker than the first derivative. Second derivative test is a bit quicker than the first derivative test, but it can be less conclusive. It's not quite as strong because we can't deal with where the first derivative doesn't exist, and we also can't deal with, we don't know what happens when the second derivative is 0. We don't know if there is no local maximum or minimum there, or if there is one. It could be either. All right, I hope this helps.